Hey Opties! Today we're talking about types of triangles based on the size of their sides. There are three ways to classify triangles based on the size of their sides. We are talking about two of them. Those are equilateral triangles and isosceles triangles. And the third type is scaling triangles, and that means that all three sides are of different length. So let's go ahead and dive into equilateral triangles. First off, we have a definition. An equilateral triangle means it's a triangle that has three congruent sides. So all three sides are the same length. Because of this, it forces all three angles to also be congruent, meaning they have the same measure. So we see a picture here when we've got some tick marks. And since we have one tick mark on each side, that means all of the sides that share the same number of tick marks are congruent. So all three sides are congruent, like we said in the definition. And we see arc marks to show congruence of our three angles. So, because we know that all three angles are congruent, we know that each angle is always 60 degrees in any equilateral triangle. Here's how we can calculate that. We know the interior sum of any triangle's angles is 180 degrees, right? Remember how in a previous video we cut off the angles and made them into a line, and that line is 180 degrees. So that's one way you could check it. So if we take the sum of 180 and we divide it by 3, we are equally distributing that sum into three parts that we know are equal, and we get 60. So that's how we know they're always all 60. Let's take a look at an example dealing with the sides of an equilateral triangle. So it says, what value of x makes triangle ABC equilateral? Okay, so we know equilateral triangles have three congruent sides. So we'll draw our tick marks. So we know that all three sides are congruent, and that means their lengths are equal. So we'll set the expressions of their lengths equal to each other. In no particular order, right? Because remember, with equality, we can change sides, and that's okay. And yes, there are three expressions because there are three sides, but you actually don't need to deal with all three of them at once. You can just pick any two of them and use them to solve for the value of x. So I might pick the first one, 3x minus 5, and the last one, x plus 1, because it just looks a little simpler to me, but it doesn't matter. Any two will work. And then we're just going to solve this equation. So we could subtract x from both sides, and we get 2x minus 5 equals 1, and then we add 5 to both sides. Continuing on, we get 2x, because this is a 0, equals 6, and dividing both sides by 2, we get that x is 3. So, set those side lengths equal to each other. Example B says an equilateral triangle with a perimeter of 48 centimeters has sides with what length? Okay, so we know the lengths of the sides are all equal. So if we said S is the length of the side, we could say that side plus side equals 48, which is the same thing as saying 3 times one side is equal to 48. And we can use that same variable because all three sides are congruent. So now we just have to solve this equation. We divide both sides by 3. And now S equals 16. So each side length is 16, and you might want to write that. Each side is 16 units, since it didn't tell us if it was inches, feet, whatever. Next, we have isosceles triangles. Isosceles means you only have two sides that are congruent. And because of these two sides being congruent, that forces two of the angles to also be congruent to each other. Now the question is which two angles, right? Because there are three angles to choose from. It's always the two angles that we call the base angles, and these are the angles that are across from the sides that are congruent to each other. So let's look at our image to make sense of that. Notice we have tick marks again. That means that this side and this side are congruent. So these two diagonal sides from what we can see right now. And then we see our third side here doesn't have any tick marks. We could potentially write 2 tick marks to show it's different, or like we had it before, have no tick marks. And then we see these two angles that are congruent to each other. And if we wanted to differentiate the third angle, we could do maybe 2 arc marks on that to show it's different. Or, like it started out, no arc marks at all. So to identify what angles are congruent, if you didn't have it already marked, it's always going to be the angles that are across from the congruent sides. So here's one side, and here's the angle across from it. That's going to be congruent to the angle across from this side's congruent side, okay? So there's two things happening here. If you know that the two sides are congruent, you know that the opposite angles are congruent to each other. However, if you start out knowing that the two angles are congruent, you know the opposite sides are congruent. So depending on what you start out with, what knowledge you know first, you can figure out what happens with the sides or with the angles. Let's say that you're trying to solve a question to do with the angles in an isosceles triangle. Well, let's call these angles A, and let's call this third angle B. We know that since these are interior angles, we could say A plus B is 180, right? But since there are two A's, we could rewrite that as 2A plus B equals 180. And that's exactly what we have written here. So we know the two congruent angles are A, the third angle is B, so 2A plus B equals 180. Let's look at example C. What is the value of X? Simple question, let's take a look at our image. So we have a triangle here, and it shows us that there are two sides that are congruent to each other because it labels them with the same length. So we also know that these two angles are congruent because they also label those with the same measure. So let's mark it up a little bit with our tick marks and our angle markings. The question is, what is the value of X? So what is one of these angles? What's the size of that? So we know that X plus 26 equals 180 because those are interior angles. We could have also used the shortcut we discussed here and did 2X plus 26 equals 180. And now let's solve this equation. We can subtract 26 from both sides. 2X is 180 minus 120 is 160, minus 6 is 154. And carrying on up here, 2X is 154 degrees, and then we divide both sides by 2. And X is equal to 25, 50, and 25, 50, 60, 75, and 2, 77 degrees. So we could double check. We could do 77 plus 26 and see if that equals 180. And we do get that, so it's a good check. Finally, we have example D. The legs of an isosceles triangle have lengths 4x plus 8 and 2x plus 16. The base has length 10x minus 4. What is the length of the base? Okay, so when it says legs, it's talking about the two sides that are congruent. So let's draw ourselves a picture, and this will be our base. Congruent angles, congruent sides. Okay, so let's label 4x plus 8 is one leg, 2x plus 16 is another, and the base is 10x minus 4. Okay, so we know that these two are congruent, so we'll set their lengths equal to each other. And we can find the value of X by solving this equation, and then to finish out the problem to find the length of the base, we will substitute that X value into the expression for the base. Okay, so subtract 2x from both sides. 2x plus 8 is 16. Subtract 8 from both sides. 2x equals 8, and divide both sides by 2. X is equal to 4. Now let's substitute into our base expression. So that's going to be 10x minus 4, and we'll substitute 10 times 4, because that's our value of X we found, minus 4, and that's 40 minus 4, which is 36. And that's a side length, so we don't need any degrees. We could say units. Let's do that. All right, Opties. That's it for types of triangles, including equilateral and isosceles. See you next time.